Hi guys, I hope you are all doing well. Let's see today's question. So today's question is from the topic of probability, and we have been said in the question that you need to select an integer from the given options of 1 to 2000. So basically we have to select any one integer out of 2000. We have to find the probability. So P is given to us that it's a probability that the number selected from 1 to 2000 is either a multiple of 3 or a multiple of 7. And once we find this probability P, we have to find the value of this 500. So we need to find the value for this expression 500 into P. So first of all, let's try to find the probability for the question asked. Now, here if I see first of all the options I have is I can select any one integer from 1 to 2000, right? And we know the idea that if I want to find probability of a certain event, that's given by favorable outcomes upon total possible outcomes, right? So if I use this idea, we already know now that total possible outcomes I have here in this case is I can select any one integer out of 2000. So I have here 2000 total possible outcomes. Now let's first of all try to calculate the favorable outcomes. Once we calculate this, we'll get the probability for that. That's P. And once we get the value of P, we can just substitute and find the value of this expression, right? So first of all, let's try to calculate favorable outcomes, and favorable outcomes are nothing but we need to find the integers which are either a multiple of 3 or a multiple of 7. Right? So let's try to do that. So if I want to calculate the favorable outcomes, so multiples of 3, let's calculate that first. Now if I calculate the multiples of 3 from 1 to 2000, I know the first multiple of 3 would become 3, then 6, then 9, then 12, and the last term in this case, if I see it's not 2000 is not exactly divisible by 3, 1999, if I divide it by 3, so basically I can use the divisibility test for 3 that says if you want to find if a number is divisible by 3, I can just use the idea that you just need to check whether sum of digits is divisible by 3 or not, right? So I can do that. So if I see 1999 gives me 9 plus 9 plus 9, 27, and 1, 28. It's not divisible by 3, so it's also not divisible. So if I reduce one more number, let's say 1998. So it's 9 plus 9, 18, 18 plus 8, 26, and plus 1, 27. So that's divisible. So the last number that is divisible in this case is 1998. So if I use the idea here, I can use arithmetic progression because difference between each of these terms consecutively is constant, that is right. So if I use the idea, nth term is a plus n minus 1d. Nth term is also given to us 1998. It's equal to 3 plus n minus 1. Difference is also 3. So what I can do here is 1998 minus 3 divided by 3. It's equal to n minus 1. So that is 1995 upon 3 is equal to n. So n minus 1 in this case becomes 3 6 are 18, 119 again, 3 6 are 18 again, 115. So 3 5s are so 665. So basically I have 1 plus 665, so 666 multiples of 3 from 1 to, right. Now let's try to also find multiples of 7. So if I try to find the multiples of 7 here, so if I see from 1 to 2000, the first multiple of 7 would be 7, 14, 21, 28. Likewise, if I try to divide, let's say 2000 by 7, the last number, it's not divisible, I know, but let's try to do that. So 7 2s are 14, 60, 7 8s are 56, 40, 7 5s are 35. So that gives me the remainder 5. And when it gives me remainder 5, that already means if I subtract 5 from 2000, I will get a number which would become exactly divisible by 7. So if I divide 1995 by 7, we can easily divide it. 7 2s are 14, 59. So 7 8s are 56, 35, 7 5s are 30. Right? So this is the last number which is exactly divisible by 7. Now here also, if I find the total multiples of 7, I can again use the idea last term is a plus n minus 1d. 1995 is 7 plus n minus 1 into difference is 7. So 1995 minus 7 upon 7, it is n minus 1 in this case becomes 1988 upon 7. So 7 2s are 14, 58. 7 8s are 56, 28, 7 4s are 20. So that gives me n is 285. So basically there are 285 multiples of 7. But now if you see the problem here that we get from these two multiples, if you see in the multiple of 3, I will also have a number 21, which will also be included in this multiples of 7 because that 21 is repeating in both the cases, right? So basically we need to find the LCM of 3 and 3 and 7 actually. If I find LCM of 3 and 7, and that gives me 21. So all such multiples of 21 will be actually counted two times if we add the multiples of 7 and 3 as well. So when we add the multiples of 3 and 7, this multiples of 21 would be actually counted two times, but we should count them only once, right? So to find the favorable outcomes, we should also subtract the multiples of 21. So let's find out how many multiples of 21 are present which have been counted two times. So multiples of 21, if I see, first up to 21, 42, 63, 84. Likewise, the last multiple of 21, if I want to find, again I'll divide 2000 by 21. So 21, if I see, 21 into 9, if I do 9 ones are 9, 9 twos are 18, so 189. And I get 110, so 21 fives are 105. So the first or the last number from 1 to 2000 which will be divisible by 21 would be 1995 again because I'm getting a remainder of 5. So I'll just subtract 5 from 2000. That will be my last term. So if I again find how many multiples of 21 are there, so last term is equal to a plus n minus 1d. Last term minus 21 because a is 21. If I take it here becomes minus 21. Is equal to n minus 1. The difference between each consecutive terms is also 20. So 1995 minus 21, 1974 divided by 21 is n minus 1. So now if I do again the division 21 9s is 189, so 84, 21 4s are 84, n is 94 plus 1, 94. Now if I find the favorable outcomes, now favorable outcomes which I have is that would be multiple of 3 or a multiple of 7. But there we already saw the idea that multiples of 21 are counted two times in this list. So I'll have to subtract the multiples of 21. We had 666 multiples of 3. Then we had 7 के लिए 285 multiples. So 285 multiples for 7, and for 21 we had 95 multiples. So now if I use this idea, what I get 666 plus 285 minus 95. 280 and minus 90, that gives me 190. 666 plus 190, that is 856. So I have got the idea for favorable outcomes, that is 856. So now if I just find the probability in the first case, I already got this favorable outcomes at 856. So it becomes 856 upon 2000. So that becomes the probability. Now we need to find, so that is the value of actually P, that is 856 upon 2000, right? But we need to find the value for 500P. So if I would find the value for 500P, it becomes 500 into 856 upon 2000. So 500 ones are 500 fours are And if I cancel this 4 with this 856, 4 twos are 8, 4 ones are 4, 16s are 4, 4. So that gives me 240. So answer for the question which is asked to us, that is a value of 500p. That becomes 214. And if you see the options which matches here in this case is, so the correct answer for the question which is asked to us is B. So this was the idea about how you should follow with such type of questions. You just needed to find the probability by using this idea, favorable upon total possible outcomes. So the idea here to find the favorable was to find multiples of 3 and multiple of 7, but that also includes multiples of 21 two times. So we also need to subtract the multiples of 21 from the favorable outcomes. And once we get the probability P, we just need to multiply it with 500 to get the answer. That becomes option. I hope you have understood how to solve this type of question. I will meet you again tomorrow with the next question. Till then, you can subscribe to my videos for more questions on this channel. Thank you.